This conference will now be recorded.
All right. Well, welcome everybody to this month's Interoperability and Technology Tech Dive webinar series. This is a monthly call that happens on the third Thursday of the month at 3 p.m. Eastern. If you want to see what other talks we've had, you can go to the IT&I Tech Dives webinar series webpage, where you can see all of our previous talks, and there's recordings for each talk. So as you can see from this list, actually, we've been hitting a number of things on Jupyter, Jupyter widgets. We covered Jupyter widgets, the Pangea project, ZAR, and a number of things that surround the scientific workflow for big data remotely and using your browser as an interface. So we're kind of going to continue in that today with Dharhas Pothina from ERDC. And he's going to talk about some new tools that allow us to interact with our data and visualize our data in the browser as part of these workflows. So I'm going to turn this over to you, Dharhas, and make you the presenter. And
okay.
All right, so let's see. And you should be able to share your screen now.
Yes, I will do that. Do you see my screen?
Yes.
Okay.
Yep. And there's Dharhas. Hello, Dharhas.
Hello. My name is Dharhas Pothina. I'm an Associate Technical Director at the U.S. Army Engineer Research and Development Center. We have been trying to move some of our analyses and technologies to the web, to browser-based systems, for a couple of reasons. One, it helps us deliver products to people who need them. And the second thing is it automatically enables us to run things either locally or on our HPC systems. So we've been looking at technology out there and also trying to see where the gaps are and kind of fill those in. So this particular project came about for me attending the Scientific Python conference a couple of years ago and seeing some of the developments with Datashader and other products to do really high density data in a browser without killing your browser. And I saw those presentations, and they were all like GPS point data or like any kind of tabular data, and decided that we needed to have this work for triangular meshes. And I went and talked to James Bednar from Anaconda, and we started looking at ways to improve the tools around Python and visualization and interacting with our stuff in the browser to build lightweight applications. The title originally said Jupyter Notebooks, but actually we are aiming past Jupyter Notebooks. For us, Jupyter Notebooks are kind of a prototyping environment, but once we have a visualization with some interactivity that we really like, we want to transition that to a standalone website, which is not based on a Jupyter Notebook. So we're also working on how do we, so everything you see today in each individual Jupyter Notebook cell, there are ways to use those without having the Jupyter Notebook running in the background or Jupyter Lab running in the background. I'm going to go through the same note. This is going to be a live notebook, so some things might break. We'll see. This is the same talk I gave a couple of weeks ago at SciPy, but I can go a little faster or slower depending on how things go. We have we're calling what we're doing EarthSim. It's actually not meant to be something you download and install. EarthSim is both a website and a GitHub repo that essentially serves two purposes. It is a place we're using to play around with new tools and get them working, before we move them into other more general purpose libraries as needed. And then it's hopefully a place to put a whole bunch of examples and notebooks of how to solve common earth science simulation, workflow, and visualization problems. So in some sense, it's similar to what the Pangeo guys are doing. It's more a place to work out how things work and then have examples other people can follow. We don't want to, and as far as possible, we don't want to develop a new package that has to be maintained. We're trying to push functionality back into larger packages in the ecosystem that are already maintained, and that way gain more visibility and have a chance of these technologies surviving in the long term. Looking kind of at what EarthSim consists of, there is a Python visualization stack, which is loosely called PyVis, which is a combination of various Python packages that together work to make a visualization of very large data sets, both easy to use and visually very scalable in the web. There's also a triangular mesh generator, which we've been working with a company called Aquaveo to pull out into a standalone open source project. And we also have another project called Quest, which is for downloading data, data management, some of the things in the background. This is a joint project between ERDC and Anaconda. And we've been working on this. We're entering our second year. So some of the things we built are very mature. Some of the things we have built are getting there, and we're still learning how they work. So I'm going to start going into the code right now. Is that visible, or do I need to make this a little bigger? Let me see.
Maybe one click up is probably good.
How's that?
That's good.
Okay. So I'm going to start by just importing a lot of stuff. If you look at the top, there's HoloViews, GeoViews, Param, Quest, Xarray, a whole bunch of packages. Those are things which are already in production and they're in the upstream packages. At the bottom, you see some stuff like EarthViews annotators, EarthSim analysis, EarthSim filigree, EarthSim IO. Those are things that work, and we have examples of how they work, so you can grab them and build your own. But we don't quite have them ready to move into another package because we're still not sure the best way to what the API should be or things like that. So that's kind of the hierarchy we have right now. I'm just going to start a Dask cluster on the back end so my computations go a little faster. Initially, I'm just going to, this next cell, I'm picking a WMTS tile server, and I'm setting it up with GeoViews, which is a Python visualization package. And I'm just adding 3 points, Austin, Dallas, and Houston. And the way GeoViews work is if you look in the end of the cell, I'm multiplying the tiles by the points. And multiplying overlays, addition puts plots side by side. So this just lets me have a nice little map that I can zoom around, and I have the 3 points, and I have hover capability over them. And this just comes straight from HoloViews, GeoViews, sorry.
Hey, Dharhas?
Yes.
Could you just say a few sentences about Dask?
Okay. So Dask is a way to distribute computations, which works very seamlessly within Python. It essentially, if you've used pandas or Xarray, the Python data structures, there are Dask equivalents that lets your code look exactly the same, but then on the back end distributes the computations onto however many cores you have, or if you have a cluster, however many nodes you have. it also lets you build arbitrary algorithms and chain things together, but does things in a lazy fashion and then computes a graph of how the computations need to happen. So then you can run computations that are bigger than your laptop memory on your computer, or you can distribute that computation over a cluster or over however many resources you have. So it's not going to be as fast as hand coding MPI for your product, but with very little effort, you can have a very scalable application.
Perfect. That was great. Thank you.
So the first thing we came up with, like in the work we're doing, is we wanted to have the ability to draw stuff on images, to draw stuff on maps, to draw stuff on any kind of image. And you can do that in a lot of JavaScript libraries. The big issue is we didn't want to just embed a JavaScript library. We wanted to be able to draw stuff on a map and then access the stuff we drew within Python. So we worked with Anaconda to add what we're calling drawing tools to the PyViz visualization suite. So I'm going to display these below. If you look up here, I have a points, polys, and paths variable, which are defined as GeoView points, GeoView polys, GeoViews path, and I've got some coordinate projections and colors and other stuff added to them. And then I'm adding these tools to the plot, a point draw, a poly draw, and a poly edit. And then I'm going to overlay all of these on the same plot by multiplying them. And we lost the corner of this. Let me see if I can expand this a little. Okay, I may have to reduce size a little. I can't see my, oh, there it is. Okay, so now I have the ability to draw points on the map anywhere I want. I can draw polylines, and I can draw polygons. Let me draw another one here. And I can also edit them. Like I can edit the vertices and say, okay, I want to move this vertex here, or I can add vertices and things like that. That's fine. There's a lot of JavaScript libraries that can do this. The thing which is new is now in Python, I have access to that data. So now I'm back in Python in this cell, and I have access to the data I've just drawn. And I'm going to look at the points. I actually have the XY locations. So you can start using this to start build as the building blocks of a larger application. Now, an example here is I am going to, this is a map of the Austin area. And I'm physically usually located in Austin, which is why I picked Austin. And I'm just going to zoom around, and I'm going to draw a bounding box. Now let's draw it over here. Okay, I've drawn a small bounding box. Now in the next cell, I now have the values of that bounding box I just drew. And now I'm going to use the Quest software, which we developed to download data from different places. And I'm going to download the USGS National Elevation Data Set 1/9 arcsecond data using that bounding box. And this takes a couple of minutes. It's downloading the raster tiles. And I guess it's got a couple of tiles the 3 tiles that make that area, and stitch them together. And then I'm going to display what I just downloaded. Give it a second. It's usually a little bit faster than this.
And is Raster.io? Oh, sorry.
Go ahead.
Is Raster.io use? Oh, I guess you're just opening it with Raster.io, so then it's also in Dask since it's an X-ray. Is that right?
That would be the better way of doing it, but when I coded this, it's our Quest software tiled the images together.
Okay. Okay.
I think. Yeah, see, if you look at the previous one,
Yeah, okay.
I applied a Quest filter called Raster merge.
I see. Yeah. Okay.
But we could have done it with Raster IO. That would have been a better way to do it.
Yeah. Okay.
And so if you look here, now I have my elevation data correctly georeferenced, and it looks correct. But so as you start having these tools, those are the building blocks to start building something interactive. The second piece we had was, well, once we draw stuff, we want to annotate it. We want to, if we draw a polygon, we want to say this polygon, the bottom friction is X, or we want to say this is marshland, or this is a boundary condition for open boundary. We want to be able to start selecting pieces of what we drew and applying data to them. So we have what we call annotators. I'm going to show you a simple one. So here, I'm going to draw a couple of points, and I'm going to draw a polygon, and let me draw another polygon, and let me see. So this polygon has, wait. Now down below here we have these tables, and this is right now this is the best interface we could come up with, because in the browser you don't really have the concept of a right click, which in a desktop tool you'd probably right click on something and change its properties. In the browser we don't have that. So for example, down here, these tables, these are the latitude and longitudes of those points up here, and now I can set values for them. I can say that this has a flag called true, this has a scaling factor of 0.5, and I'm going to call this, USGS gauge 5, whatever. Now that is associated with that point, which is selected right here. I can also decide I want to change the latitude longitude to something else. I'm going to say 4.5. Actually, that's probably a bad idea. Let's change this. Let's make it 101. And that will change the location of that point in that. It's a two-way connection. Now, for the polygons, I can say maybe this is a mesh type paving, or this is a material type. Oh, I think mesh type. I guess this is set up as a number, something like that. Now, to set that up, all I did was up here, I said the polygons have these columns, material type and mesh type, and the points have the columns name, scaling factor, and flag. And that's all we had to do. And the vertices have weights. So that's all we had to do, and it automatically set up all the connections between the objects we're drawing and a way to annotate those objects with data. This part of it we're still working on. We have a couple of people trying to use this for mesh generation and other things, and so we're not completely satisfied with the best way to do this, but it's currently working well enough that you could actually use it to build a bigger application.
Hey, Dharhas.
Yes.
So when you were editing those numbers, it said latitude and longitude, but there are clearly some projected coordinate. Is that something you're still?
That can be changed. It's more when we set it up. That's easy to change. It's just when we made this demo, I didn't set it up so you could do it in lat long, but you could have it set up so you would be typing in lat long.
Okay.
That would not be difficult to do. Again, that's one of those things where it's a usability thing. This is setting this up as we have a class with about 100 lines of code which sets this up. You could change that anytime you want, or we could make that a standard class you could inherit and do other things with. So yeah, like if you look down here, this one actually shows you in latitude, longitude. And
yeah,
so it's more a case of the way I set it up. was slightly wrong. So this one is in latitude, longitude. I can change this to 31. The other one wasn't. And that's probably just because I forgot to set the coordinate system in that code for this cell.
Okay.
Okay, this is another example of how you could potentially use this for an application. I'm just going to draw a polygon along the Texas coast, Texas-Louisiana coast. Assume this was the coastline, really bad coastline. And now I'm going to say, I'm going to give it a couple of points. Oops. And at one of those points, I'm going to say the mesh size is, again, this is in bad coordinate systems, so I don't have a good way of setting this. So let's try this. I'm going to set the mesh size of those 2 points. And if I hit update mesh, I should get, you can't really see that they're different. Okay, let's try again. We're still working on our mesh generator interface, so once we have that, yeah, okay, you can kind of see that a little better. Maybe not.
Yeah, we get the idea.
You get the idea. The idea is you should be able to set, you can start controlling your application. I'm also going to show this because this is the thing which, when it started working, I was super happy and was like, okay, even if the rest of the project doesn't work, I'm good. And this is triangular unstructured mesh visualization on really large data sets. And give it a second to read the data in, and
so that's 8 million nodes.
I think it was 8 million. That's why I got the tail there to kind of look at it. Right now we need to optimize a bit. Initially loading the data takes a few seconds. Once it's loaded, it's really fast to interact with. There are things we know we need to fix to make the loading faster, but it's on our to-do list.
Yeah, I guess it's worth pointing out that we didn't even have a way of rendering,
yes,
say, an 8 million node grid. Yeah. So
and
now
it's been really slow on my computer today.
It's read the data, and now it's waiting to what?
This particular data file is in UTM-18, so it's actually reprojecting the data. And
okay.
Oh, there it is. So if I scroll down here, actually, let's go over here. This is 4 million vertices. I think it's 8 million triangles or something like that. But if you see, if I zoom in here, a couple of seconds it'll take to refresh, and you have full interactivity at very high resolution. And you can zoom in and zoom out. You could overlay other data on this. You could have velocity vectors, quiver lines, all that kind of stuff. And it's really responsive. You will never crash your browser because it's only sending 800 by 1,000 pixels each time. On the back end, and architecture-wise, there's not a limit to this. If you had a cluster on the back end which could do the chunking of your data, it would do whatever size data you needed. I have tried it with up to 20 million triangles without a problem. And now I'm starting to get to the point that no one has bigger meshes because they couldn't visualize them before. So I'm super excited about that.
That is so exciting. Yeah, it opens up a whole new.
And also attaching that stuff to the tools we built start letting you do things like this. I'm not going to demo this one because there's a bug that is fixed in master, but not in the version I have. But here you have a mesh with bathymetry data, and as you draw lines on this mesh, it automatically populates the bathymetry on the other side. And if I don't know if you can see this, but as I'm moving this back and forth on this, you can see a little red and blue dot moving on those two cross sections. Let me zoom in. You might be able to see it better. So, as I'm moving here, you see those red dots? Might not be visible in the webcam, but you can start having an you can start playing an animation on one side and draw a line through the animation and pull out a vertical profile at that point, which is also animated. You can start doing things like that by connecting all these tools together. And the idea is it's only like 2 lines of code or 3 lines of Python code to set it up.
That's cool.
The last one I will demonstrate is GrabCut. And this is using a GrabCut algorithm from a computer vision package called OpenCV. And the way the GrabCut algorithm works is as you tell it what the foreground and background is, it iteratively separates the foreground and background. And the more data you give it, the better it does that. And so, for example, here is an estuary, and I'm going to define what I think the background is. I'm just going to put a couple of lines in the areas which I think are background, or like I want to separate, basically. And then I'm going to put a couple of other lines in the areas I consider foreground. Okay, now I'm going to say update contour, and this will chug for a couple of minutes because I have a fairly slow laptop, and it is going to try and separate the foreground from the background. And we may have to wait a little bit for this to show up because I have a fairly slow computer right now, since I'm not on my desktop. Oh, and there it is. So there is your coastline based on me drawing those 4 or 5 little lines. And you could clean this up some more. You could run some more filters on it. You could also combine this with my earlier one where we drew a box and we downloaded data to actually say, let me draw a box and download data, and now let me run the contour on it and start. So right now we're kind of building these are the kind of the building blocks which could be used to start building fully featured mini applications designed to do one thing. Our hope is we play around building a workflow in Jupyter notebooks, getting everything working. Once we have everything working, we kind of have this kind of GrabCut dashboard or some kind of view that we actually want our end users to use. And then we can transition that to a separate website which hides all the code and just has that dashboard-like application with different pieces connected to each other and buttons and widgets and controls that let you do something. Instead of having a monolithic application that does everything, we just have these little targeted applications that do one thing at a time. We're also working out how do you string those together into kind of like a workflow with hit next, do the next thing, hit next, do the next thing, and stuff like that. That was my demonstration. Future work, we need better documentation. Most of the documentation was written by developers who don't have a earth science background, and so it's a little software speaky. We need to kind of clean it up. We have bugs and usability stuff we're doing. All this stuff works right now. As we're using it, we're actually using it in-house to try and do certain different workflows. Like one is a dam break problem where we want to see what happens when a dam breaks. Another one is a hurricane simulation where we want to draw in the path of a hurricane and put a pressure field along that line, and then let our model go on HPC and then visualize the results. So we're kind of playing around with different workflows using these tools. And as we're playing around, we're like, oh, we really need a freehand draw tool. Oh, we need an undo button. And so we're kind of learning the things which are missing and then trying to work out how to put those in. Things which are should be coming in the next 6 months or so is conversion of these into standalone dashboards easily. Conversion of the Datashader output, which I showed earlier here. So when I did that really large triangular mesh, this is using Datashader on the back end. This is great when you have a live Python instance behind it, but it won't work if you don't have a Python instance running in the background. So we want to be able to click a button on this and export all the this mesh visualization data to WMTS tiles, and that way if we stick it up on a static website, we can just serve the tiles and be able to serve a larger group with that data. We're looking at parameterizing Jupyter notebooks. So if you have a notebook that defines a workflow, say these are the inputs, these are the outputs, and be able to string multiple Jupyter notebooks together. For some reason, currently the plotting library at the back of this Bokeh cannot draw polygons with holes. So we're going to be adding that in, and then various optimizations for tri-mesh, quad mesh. Right now, all this is working without any kind of R3 spatial optimization. We'd like to add that, which would speed up interactivity even more. We're also playing around with, if you've ever used ArcGIS Model Builder, where you can have different pieces of a workflow and you join them with lines and you say, okay, this is the input, this is the output, and that kind of things. Because of the technology we're using on the back end for some of this stuff, we kind of would get that for free. So we're going to have a prototype version of that. We're not sure if it's going to be useful or not, but we're going to be playing around with it. We have a website and a GitHub repo. This particular notebook is on GitHub. I think that's all I have to say. Open to take questions.
Okay, Dharhas, fantastic. Thank you so much. I think I'll just open it up. I have some questions, but I'll open it up to everyone else to ask questions first. And you're probably muted either by me or by yourself. So if you want to ask a question, just go ahead and unmute yourself and ask away. Okay, well, I'll just start things out then. So if you attend a meeting like SciPy, you hear about a lot of different tools for interacting between JavaScript and Python in the browser, and like Jupyter widgets. We had a talk on Jupyter widgets actually by Jason Grout a few months ago. This is not Jupyter widgets, right?
This is not Jupyter widgets. We started off with Jupyter widgets, but unfortunately, the developers of a lot of this stuff have talked with the Jupyter guys. Unfortunately, the Jupyter guys have a Jupyter-centric world. And pretty much anything you build on top of Jupyter widgets is probably not going to work outside of Jupyter. And while I love Jupyter and I think it's great, eventually we don't want the stuff we're building to be locked into having to run inside Jupyter. Currently, the dashboards and the GrabCut, all the things which we are currently building should be able to work in a standalone web browser using a Bokeh server on the back end. We've actually even got a prototype of it working inside a Django web application. And so we don't want to have to recode our stuff because we have to go into a Django web app or a standalone website. So one of our primary design criteria is we have to be able to run this stuff outside of Jupyter.
Right. Okay.
And so cool. That's the problem. Right now, Jupyter, one of the Jupyter widgets they showed for 3D visualization is amazing. We wish it was compatible outside of Jupyter. And some of their widgets are compatible, but it's like right now the situation with Jupyter widgets is there's some stuff that only works in Notebook, there's some stuff that only works in Jupyter Lab, there's some stuff that can work outside but works differently.
Right.
So it's unfortunate.
Right. Anybody else with a question? If I could just actually, Dharhas, you know, one thing that I think is amazing of this project is at the beginning, you know, you're a government like basically this to meet your own goals. You're helping to build the tools which you already depend on, and also doing them in existing packages, so you don't have, like you said, so you don't have to develop, you know, whole new packages and the whole communities that support those. Could you bring up I just think there's something kind of raised an issue on EarthSim issues. Maybe you could just bring that up real quick.
Yep.
So after seeing this talk, I realized that we could use this for a workshop that we were doing. And the piece we were missing was interacting in the browser in the way that we wanted to for this application. I think it's a closed issue, like the latest closed issue, maybe. Yeah, that one right there, the top one. So, so 7 days ago, I raised this issue, and I just want to bring this up because it illustrates the power of this sort of open source approach and having a community behind these tools. So I posted an issue and said, hey, you know, wouldn't it be great if, in addition to like the polygon kind of clicking and stuff tools that that Dharhas showed, if you could actually have a freehand drawing tool which will allow you to do this annotation in kind of a natural way, and that's showing annotating the beach and the water, and you go through these different things. So I raised that 7 days ago, and James Bednar immediately answered back. And then Philip from the project answered back, and he said it's on our to-do list right there in the middle, but I haven't started working on it yet. And then basically, if you raise that, oh wait, no, so there down below, he says on the very same day, he said, I decided to have a go at it.
Yeah.
And he did it. I mean, he.
Yeah.
so he basically, you know, from wow, wouldn't it be great to have this feature to hey, I just implemented this thing, and I mean, this is the beauty of open source and having developers who are really into, you know, building this functionality. I mean, this was already on your roadmap, I guess, but.
No, this was already on our roadmap, but the thing which I've learned is some of these things are on a lot of our roadmaps. And when we start sharing it, two things, it validates our design choices, and also we get to leverage each other's work. Because, yeah, so if Datashader and Bokeh and iViz were not already open source, we would have no hope of doing what we're doing right now. So.
Right. Yeah, so I, you know, as a USGS person, I know that, so ESIP being, you know, NOAA, USGS, a lot of other federal agencies participating, I like to put this example up of what ERDC is doing here as an example of what our agencies, the way that all of our agencies should be helping to support the community that we depend on for getting our work done. All right. Well, does anybody have any other questions? All right. Okay. Well. Okay. So actually, somebody chatted on the geodata format. I guess he means the data, the format that you use to load your, say, your tri-mesh data. Or is that right, Roland? Right. Yeah, it was like it came in some, and you loaded it into a data frame, but it wasn't clear, I guess, whether the columns had to be formatted in a certain way.
So that's still not, that needs to change, because right now, the way we specify how to draw the tri-mesh is by putting the data in. It's basically the same node and connectivity information, but they're putting it in a pandas data frame and then providing it a tri-mesh. That's probably not the best way to get the data in. It's more a case of when Anaconda was building that tri-mesh functionality, we didn't give them much guidance in like a standard way to get the data in. So they just picked one. And we'll probably revisit that and maybe say, oh, just give it a NumPy array, or, you know, so that's something that can change. Right now, you just, let me see if I can go back to that.
Just you still have that browser tab open there.
Oh, can I switch browser tabs? Okay, there we go. I thought it was locked to this one tab. Okay, so right now, you have to give it tri-mesh. You have to give it the edges and the points. So this, so the first one, this xtries is a pandas data frame that has 3 columns that define the 3 node connectivity, and the points are just your XYZ vertices as a GeoViews points object, so it knows the correct projections and stuff. If it made sense to make it something slightly different, so getting your data into Python and converting them to this is currently, you do it however you want. And in this case, if you look at the triangles, they have a V0, V1, and V2 for the 3 vertices. Does that make sense?
Yeah, and like you said, I mean, it's really kind of arbitrary. You could just do almost anything else pretty easily.
You can do anything else pretty much easily. It was basically a case of, they asked us if there was a standard format that everyone in unstructured grids, triangular meshes uses, and I laughed at them, and they picked this.
Okay. Well, they could certainly read the UGrid conventions.
It could. It was more a case that none of our data internally to ERDC is currently in UGrid, which I'd like to change. But there wasn't much thought put into that particular aspect, and a better option is definitely available.
Sure. Okay. All right. Well, if there's no more questions, then we can end a little bit early here. Dharhas, thank you so much again. This is super cool stuff, and we're already using this in several of our workflows, just mooching off your work, I guess. But hopefully we'll be able to contribute to these same packages, and hopefully someday you can benefit by stuff that we add.
Sounds great.
Okay, so this will be, folks, let other people know about this recording. It'll probably go up tomorrow, and it'll be available off that page. If you want to get notified of future meetings, you go ahead and join our mailing list there by going to the webpage I showed at the beginning. ITNI, Tech Dives, ESIP should get you there. Okay, thanks again, and we'll see you in a month.